Here I will explain op-amp parameters. Input offset current. Input offset current. The input stage of op-amp is the dual input differential amplifier. Dual input differential amplifier. DA means differential amplifier. Dual input differential amplifier. And the input terminals are the base terminals of the two transistors. These are the two input terminals of the differential amplifier are the base terminal of the two transistors shown in figures. Two transistors which are used to construct this input differential amplifier. The base terminals of the two transistors are nothing but the input terminals of the operational amplifier. Input terminals of the op-amp are the base currents of the two transistors Q1 and Q2 used in the input stage. Q1 and Q2 which are used at the input stage of the operational amplifier. Q1 and Q2 are perfectly matched. Therefore, the base currents are equal. IB1 is equal to IB2 ideally. But practically, the two input base currents differ by small amount. These two base currents are differ by small amount. Therefore, practically, these two base currents are not equal. IB1 is not equal to IB2. The algebraic difference between the currents flowing into the two input terminals of the op-amp is called as input offset current, and it is denoted as IOS. This is the IB1 current. Plus 1 is minus 1. This one is IB2 current. The algebraic difference between the currents flowing into the two input terminals of an op-amp is called offset current. Difference between these two currents, IOS, input offset current, is IB1 minus IB2. Mathematically, it is expressed as IOS is equal to mod IB1 minus IB2, where IB1 is current entering into the non-inverting input terminal. IB2 is the current entering into the inverting input terminal. Ideally, IOS is 0, while for op-amp 741C, maximum value of IOS is 200 nanoamperes. Coming to input bias current, another parameter of the op-amp, two base currents of the op-amp are IB1 and IB2. The average value of these two base currents is nothing but input bias current. The average value of the two currents flowing into the op-amp input terminals is called as input bias current, and it is denoted by as IB. IB is equal mod IB1 plus mod IB2 by 2. Ideally, it should be 0 because in ideal case, IB1 is equal to IB2 is equal to 0. But for 741 op-amp, 741C op-amp, maximum value of IB is 500 nanoamperes. The two input terminals of the op-amp are nothing but the base terminals of the two transistors which are used to construct the input differential amplifier. The two base currents are IB1 and IB2. The two transistors which are used to construct the differential amplifier are perfectly matched. IB1 is equal to IB2. These practically it is not possible. Some difference amount is there. IB1 and IB2 are differ by some amount. Therefore, input offset current IOS is equal to the algebraic difference between these two base currents, mod IB1 minus IB2. Ideally, its value is 0. Practical case, its value is for 741C IC, maximum value of IOS is 200 nanoamperes. Consider average current also, that is called as input base current. IB1 and IB2 are the base currents or input currents of the operational amplifier. The average of these two base currents is nothing but input bias current. Ideally, it should be 0. 741C maximum value of IP is 500 nanoamperes. Coming to next parameter, input offset voltage. Input offset voltage, it is represented by VIOS. This is the 741 op-amp. Both terminals of the op-amp is grounded, is at ground potential. Non-inverting terminal of the op-amp is connected to ground potential. Inverting terminal of the op-amp is connected to ground potential. At this stage, the output voltage ensure that the output voltage V0 is equal to 0, definitely. But ideally, V0 equal to 0, practically it shows some value other than 0, a small output voltage is present. Here, whenever both the input terminals of the op-amp are grounded, these two input terminals are grounded, ideally the output voltage should be 0. However, in this condition, the practical op-amp shows a small non-zero output voltage, this one. To make this output voltage, our aim is to make this output voltage is 0. What to do? A small voltage in millivolts is required to be applied to one of the input terminals. A small voltage in millivolts, VIOS is in millivolts, is applied to one of the input terminals. In this case, this small millivolts voltage is applied at inverting terminal of the op-amp. Sometimes a small voltage in millivolts is applied to non-inverting terminal also. Depends on the manufacturer's data sheet value. To make the output voltage 0, small voltage in millivolts is required to be applied to one of the input terminals. Such a voltage, that is VIOS, makes the output exactly 0. The DC voltage which makes the output voltage 0 when the other terminals is grounded is called as input offset voltage, denoted as VIOS. In order to make the output voltage V0 equal to 0, a small voltage in millivolts is applied to either of these terminals. In this case, that small millivoltage is applied to inverting terminal of the op-amp. Other terminal is connected to ground. These two conditions are satisfied. Therefore, V0 equal to 0. How much voltage? That means this one, how much voltage? How much input offset voltage is applied to which terminal? To which terminal means either inverting terminal or non-inverting terminal with what polarity? What polarity? To be applied is specified by the manufacturers in the data sheet. The input offset voltage depends on the temperature, VIOS. Temperature changes, VIOS is also changes, output voltage of the op-amp is also changes. Here, another way of reducing the output voltage of the op-amp, DC output voltage of the op-amp is to 0 when both the input terminals are grounded is consider two DC voltages, VDC1 and VDC2. Therefore, input offset voltage VIOS is equal to difference between these two voltages will require, that means mod VDC1 minus VDC2 will require to set the output voltage is 0. Therefore, in that case, VIOS is equal to mod VDC1 minus VDC2. VIOS is also temperature dependent. VIOS can be, input offset can be positive or negative. Hence, absolute value of the VIOS is mentioned in the data sheet. The smaller the value of VIOS, better the matching of the two input terminals. Matching of the two input terminals means base current IB1 is equal to IB2 is equal to 0. Their input offset voltage depends on temperature. Many times voltage to one of the input terminal is applied. That means VIOS is applied with the polarity, with proper polarity, so as to null the output voltage. That means V0 equal to 0, keeping other input terminal is grounded. This one is other input terminal is grounded. For ideal op-amp, VIOS is 0. For ideal op-amp, VIOS is 0. Hence, practical op-amp model is generally shown in figure, this one. With the indication of the input offset voltage, for op-amp 741C, the input offset voltage is 6 millivolts. These are the 3 important parameters of the operational amplifier. In the next video, I will explain another parameters